Yeah, so counting numbers. 1, 2, 3, 4, dot, 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 dot. Okay, then what's the difference between natural numbers and whole numbers then? Good. Okay, it includes 0 as well. So the only difference it includes 0. Right? Then what about integers? What are integers? Yep, 7. Also negative. So for example?
It's minus 4 to minus 4.
Yeah, minus 4, minus da, 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 1, 2, da, 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 da. Anything. So is negative 100 an integer? Yeah. Is negative 100 a whole number? Right? Because whole numbers are only positive numbers, including 0. Okay. There are two main types of numbers, rational and irrational. So all numbers are part of the real number system. So there are some that are rational, some are irrational. So what's the difference between them? Rational numbers can be written as a fraction using integers, but the denominator, the bottom number, cannot be 0. Okay? It has a terminating decimal, or it has a repeating decimal. So can somebody tell me an example of a rational number? Yep. Oh, was your hand up? Sorry. No, sorry. Everybody's like hiding their hands now. Yeah, don't worry. Like participation, and even if you get it wrong, it's okay. Nothing to lose. Okay. Example of a rational number. Isaac. Okay. 1. Yeah. 1/1 or just 1. Okay. 1's a rational number. Alright, other than 1/1, give me another fraction. Yep. 2/3. Yeah. Right? 2 is an integer, 3 is an integer. So 2/3. What is 2/3 as a decimal? Yep. 0.66666 like this, right? So it's also a repeating decimal. Right. What else? Another example. This is an example of a terminating decimal. So a decimal that ends. 1/2, yeah. So another this. What's 1/2 as a decimal? 0.5. So you see, a decimal that ends. Okay, so those are examples of rational numbers. Irrational. Oh, sorry. what a word plot to have a hole punch. So this is supposed to be irrational. Irrational numbers. Okay. So irrational numbers are numbers that cannot be written as a fraction using integers, and a decimal that goes on forever, but it doesn't repeat. So like unlike these ones. So what are an example of an irrational number? Miriam? Pi. Good job. Pi, as you guys know, 3.141596 blah 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 blah. So it goes on forever. Okay. Another one? Square root of 2. Excellent. Good examples. Okay. Square root 2, it's like 1.41 something 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 something. So again, it goes on forever. It doesn't end. All right. If you have to guess on a test, most likely it's a rational number. Okay. So let's go over these ones then. So some examples of rational and irrational numbers, and tell me why. So this one, 3/4, is this rational or irrational? And why? Good. Rational, terminating decimal. Okay. 2/3. Oh. Rational because repeating decimal. Repeating decimal. Okay, 5 over 11. Yep, rational. Why? Good. 5 over 11, if you're not sure what it equals, I'm doing a bad example right now. I'm using my cell phone calculator. Okay, you need a calculator for this course and not the cell phone calculator. So I so 5 over 11 is the same as 5 divide, oops, 5 divide 11, and you get this, which is a repeating decimal. Right? Another way that I know it's a rational is because it's a fraction of integers. Integers. 5 is an integer, 11 is an integer. Okay. And then, well, we kind of already know these two. You guys chose nice numbers. So, root 2, rational or irrational? Miriam? Irrational because it doesn't end. Yeah, so um, decimal decimal doesn't end. Okay, or decimal goes on forever. Okay, and pi.
Rational.
Sorry? Rational? Irrational, right? Irrational. Okay, and it's also because decimal goes on forever. Doesn't end. Okay. So there you go, 7.5 minutes. There's your first ever math lesson. How was it? Good. All right. So on the back are some homework questions, but you still have 20 minutes. You can finish this in 20 minutes and have no homework this weekend. Right? This is a really good diagram for you to memorize or remember. It really helps. So you see how there's like circles within the circle? That means natural numbers are part of whole numbers. That means whole numbers are part of integers. And then, so for example, these rational numbers are not integers because they're outside of that circle. Right? And everything is under the real number system. Right? So for example, is negative 22, is that a whole number? No. Is that an integer? Yes, because it's inside this integer circle. What about 72? Is that a whole number? Yes, it is because it's within the whole number circle. Is 72 integer? Yes, because it's within the integer circle. So like anything in this big circle, that's considered integer. Okay. What about negative 3? Is negative 3 a rational number? Who says yes? Negative 3 is also a rational. Yep, it is because it's all inside this big circle. What about, is negative 3 a whole number? Who says yes? Who says no? Right, because it's outside of the whole number circle. Okay. Pi. Is pi an integer? Who says yes? Who says no? Pi is not an integer. Okay, last time I checked, I had 28 people in the class. Right now, I see like 5 hands up. Okay, pi is not an integer because this is the integer circle. Pi is obviously on the outside. What about root 72? Is that a real number? Who says root 72 is a real number? Who says no, is not a real number? Remember, everything is real. Everything is real. Okay, so all of this. That was a tricky question. All right. So what's the opposite of real? Fake. Yeah. So the fake number, but that sounds like so fake. So in grade 11, you learn about imaginary numbers. So it just sounds better than fake numbers. So for grade 9, grade 10, you guys will all learn about just these numbers, the real number system. When you get into grade 11, that's when we talk about imaginary numbers. Okay, so uh, 20 minutes, try these out. I'll come around the room. You should be able to finish all this before we go. Yeah, and then we'll take this up on Monday. And just to set good homework habits, I'm gonna do homework check on Monday. Okay, but it's doable. It's just this. It's just this one page. You can do it. Make me proud. Okay, so I just finished recording this lesson. I'm gonna throw it up on YouTube so that if you need, you can review it at home over the weekend. Okay, sounds good? Let's get working.